So this is the first video dealing with section 7.2, which is estimating a population mean. Remember, the notation for a population mean is mu, right? In many cases, a population mean is something that can be very difficult to calculate, especially when you're dealing with larger populations. So in order to try to estimate the unknown population mean, we're going to go out and grab a sample of people and find the mean from that sample. We call that X bar, the sample mean. And we're going to use the sample mean to try to estimate the population mean, right? So just some more notation here, just to kind of review it really quickly. The sample standard deviation, remember, is S, and the population standard deviation that comes from the population is sigma. So some key concepts: the best point estimate, right? The sample mean X bar is the best point estimate, or single value estimate for the population mean mu. So what that's saying is that when we have this unknown population mean here, what is the best value that we actually have to try to estimate it? Well, the sample mean, right? Grab a sample, a randomly selected group of people, find the average, and this is the best single value we have to try to estimate this unknown population mean. Second part, or second key concept, a confidence interval, right? We can use a sample mean X bar to construct a confidence interval to estimate the value of the population mean mu. The last key concept, we will find the sample size, or the necessary sample size, to estimate a population mean. Okay, so we're going to start with part one. Okay, this section's broken up into two parts. And so first, we're going to look at estimating a population mean mu when the population standard deviation is known, right? So what this is saying is that somewhere in the problem, they're going to tell you the population standard deviation. It's given in the problem. So a lot of times you'll see the phrase, the population standard deviation is this, or you also see when they're talking about the population standard deviation, a lot of times the phrase that they will use is the standard deviation is known to be blank, right? When they say that, they're typically referring to that population standard deviation. So the population standard deviation is a well-established value that comes from other studies. If the population standard deviation is given in the problem, they tell you what it is, then you must use the standard normal distribution, and we're going to be calculating z-scores. So basically, we're going to be creating what we call a z-interval, right? So just to go back over, we already used these values in the previous section when we were creating confidence intervals with proportions, right? The previous section. So remember, your z-scores are based off of your confidence level, right? And so our three main confidence levels were 90%, 95%, and 99%. And the confidence levels that corresponded with the z-scores that corresponded with those confidence levels was 1.645, 1.960, and 2.576, right? Those were the three z-scores that corresponded to the confidence levels, right? As your z-scores get larger, right, that's going to create a wider interval, which means you're going to be more confident, right? And so your z-scores tell you how wide your interval is going to be. And so we're going to begin by constructing a confidence interval. Constructing a confidence interval for the population mean mu when the standard deviation is known. I don't know how much I'm going to stress this. The standard deviation is known. It's given in the problem. Okay? In order to create your confidence interval, you need to be given or you need to calculate two values. So that you need to know two things to construct your interval. You need to know x bar. That's the best point estimate. And you need to know your margin of error, right, to construct the confidence interval. Below is three ways to represent your confidence interval. Okay, you can either write it as x bar plus or minus e. So this should be x bar plus or minus e. X bar minus e is your lower limit here. X bar plus e as your upper limit. And then the last one is x bar minus e is less than mu, which is less than x bar plus e. So this is three different ways to write the exact same confidence interval. And so then to calculate your margin of error, when sigma is known, they give you that in the problem, we use critical z-scores, right? So to calculate your margin of error, it's z sub alpha over 2. So the critical value here, that z-score corresponds to the confidence level, right? Times your margin of error divided by the square root of n. I apologize. I think I just called this the margin of error, but this is the population standard deviation, sigma, over the square root of n. Okay, so let's jump into an example. A sample of the reading scores of 35 fifth graders has a mean of 82. The standard deviation of the population is known to be 15. So let's kind of break apart this. So first of all, we have a sample of the reading scores of 35 fifth graders. So 35 fifth graders, that's going to be n. That's going to be how many fifth graders we had, right? Has a mean of 82. So the mean here, is this x bar or is this the population mean? Well, it comes from 35 fifth graders. So this is actually going to be from a sample, right? So this is going to be x bar. The standard deviation of the population is known to be. So there's two keywords here, population standard deviation and then is known to be. This guy 15 here, that's the population standard deviation, that's sigma. So sigma is known, right? That's how you know if sigma is given in the problem, you're going to use z-scores. And we're going to be creating a z interval, right? So let's answer some questions. State the best point estimate for the mean reading score of all fifth graders. Well, when we're looking at estimating the population mean, we're trying to estimate the mean reading score for all fifth graders. We don't know that. What is the best point estimate? What is the best number we have to do that? Well, it's x bar. It's the sample mean. So the best point estimate is 82. Second part, find the margin of error that is used to construct a 99% confidence interval to estimate the true mean reading score of all fifth graders. So here, we're just trying to simply calculate the margin of error. Well, in this problem, sigma is known, right? They gave us sigma. And so we're going to have to use this formula for margin of error that involves the z-score and also involves sigma, right? So we have to plug in our information. To get the z-score, it comes from the table above. We are at a 99% confidence level. So the z-score that corresponds to that is 2.576. Your standard deviation that comes from the problem, sigma, is 15. Divided by the square root of n, we have 35, a sample of 35 fifth graders. So you type this in and get your decimal back. And so your margin of error right, is 6.53135 and so on. Okay, so now they're going to ask you to round, but that is your margin of error. Construct the confidence interval to estimate the mean reading score of all fifth graders. So here we want to actually construct the confidence interval. To construct the confidence interval, you need two things. X bar, you need that best point estimate, and you need your margin of error. Well, X bar is 82. Your margin of error was calculated on the previous step here. So it's 6.531, just going out 3 or 4 decimal places, and then you round at the end. And so to actually get the lower limit and the upper limit, right, you have to add and subtract those numbers. So to get the lower limit, you have to subtract 82 minus 6.531. And they'll probably ask you to round to 2 decimal places here. So I'm going to go ahead and round. That's 75.47. And to get your upper limit, you add those two numbers. And you end up with 88.53. So the last part, interpret the interval. Well, what this is saying is that the true mean reading score for all fifth graders is between 75.47 and 88.53. And I forgot to write that we are 99% confident. So we are 99% confident the true mean reading score for all fifth graders is between 75.74 and 88.53. So let's look at how to do this in the calculator. So that was how to do it by hand. Okay, to do this in the calculator, we're going to create the same interval from this part, from part C, but we're going to use the calculator to do it now. So we're going to construct a 99% confidence interval. So you press the stop button. You go over and select the right arrow twice to highlight tests at the top of the calculator. And you scroll down and press number 7. We're creating a Z interval, right? We're using Z scores. So press enter. And there's 2 options here. Data is if you're actually given a data set, which we'll look at that a little later, but we are actually given stats here, right? We're given some statistics. So go over to the right, press enter, and you're going to enter the information, right? We have sigma is 15, X bar is 82, and N is 35, and our confidence level is 0.99. So 15, press enter. X bar was 82, N was 35, and our confidence level was 99%, so as a decimal is 0.99. And then go down, press enter, press calculate. And so this is what the calculator gives you, 75.469 and 88.531. And rounding to 2 decimal places, you end up with 75.47 and 88.53, which is, if you look up here, was the exact same interval, right? So this is doing it by hand, and this is doing it in the calculator. Either way is fine with me. Okay, the homework does ask you a lot of questions similar to these, where the first part is the best point estimate, the second part is the margin of error, and the third part is actually creating the interval using the first 2 steps. So, you know, however you want to do it is fine. You can use the calculator if they just ask you for the interval, and then you can do it this way if they ask you multiple parts. So we're going to continue in the next video discussing part 2 of this section.